can we estimate the points at which the parabola intersects the two lines? Well, we already have an estimate here because I just happened to draw it so the vertex looked like it was on the line, right? So we could plug these coordinates into the equation for this line, which is here, right? Okay? So if x is 5 halves, well, 9 halves times 5 halves is 45 fourths, right? And we add 45 fourths to negative 27. Well, actually, negative 45 fourths, right? And 27 is 108 fourths. Negative 45 and 108 is 63. Okay? So we're getting 63 fourths. Okay? Which is 15 3/4. And we estimated 14 1/2. Understand what I just did? I plugged these points into the equation we got for this line, and the x-coordinate gives us something that doesn't quite match the y-coordinate. We get 14 1/2 for y, and if I did it right, we get 15 1/4 here, right? 15 3/4. So it's off by a little bit, but it's not implausible because we're doing pretty rough estimates, right? Okay? Okay, so the other thing I want to figure out is where would the parabola intersect the second line, the y equals 3/2 x plus 9. Well, we can do this easily. Same way we do it with two equations. We eliminate a variable. Okay? So we could write out y equals 6/29 times x minus 5 halves squared plus 29 halves. And negative y equals negative 3/2 x minus 9. Okay? If we add these equations, y flutters away into the ozone. Okay? And we get 0 equals negative 3/2 x plus 6/29 times x minus 5 halves squared plus 29 halves minus 9. 9 is 18 halves. That'd be 11 halves. Okay? Now what are you going to do with, now everybody understand what I just did? It's pretty straightforward. I just took these two equations, wrote them down, multiplied the second one by -1 so the y's would go away, right? And now I have an equation for x. And x is the only variable. What am I going to do with this mess? Well, what's the first thing you think I really need to do? I need to square x minus 5 halves, right? Well, got time, doesn't take long. Negative 3/2 x plus 6/29 multiplied by x minus 5 halves times x minus 5 halves plus 11 halves. We use the distributive law, and incidentally, not everybody used the distributive law when I said to use it. People used lines and pictures and stuff that were equivalent to distributive law, but very specifically, the distributive law, you write the thing out, okay, when I ask you to. If I don't ask you to, yeah, you can do whatever, okay? But you have to show me you know how to use the distributive law. And most people that did it by black magic did it right on the problems we had binomials and screwed it up with trinomials. Okay. That's why you need to use it. Okay. So we get x squared minus 5x plus 25 fourths plus 11 halves. It should be clear that I can then multiply through by 6 over 29 using what? This blamably distributive law. Okay? And I'm going to get something times x squared and something times x and some number, right? And then whatever number I get from this adds to the 11 halves and the negative 3 halves, right? And all of a sudden, I have the form ax squared plus bx plus c equals 0. And I can either try to factor that, which is not going to be successful, almost 0 probability, okay? Or I can use a quadratic formula to solve it, and I get an x coordinate, which should be the x coordinate where this graph crosses this one. Okay? So solving that quadratic should give me the point where these two graphs meet. All right? So I estimate this point, and yeah, you can do that, and see how close my estimate comes to my solution. Now my solution's probably going to have 47 decimal places, just rounded off to 2 or 3 significant figures. Okay, we don't need any more than that. We're just doing ballpark estimates here and comparing. Saying that we're off, but we're probably not off that much. And then in the process of doing this, you figure out if you're doing everything right. Okay? If you're doing everything right, then your estimates are going to come out close to your solutions. And if you aren't doing everything right, see if you can fix it. If you can't fix it, try to identify where you're not confident of it, and then we can help address that, right? Okay? Okay, very good.